Welcome back to Machinist Made. Today we're going to do some 3D contouring and 3D trace inside of Fusion 360. So I've got this part here. You can see obviously this has a funky shape to it, and we have a three-dimensional letter that is clearly also defined on that arc. The way you would do this, you would start off by creating a simple setup. We're going to go to Setup, Orientation ZX. This part's a little different than parts you've probably done in the past, since this contour is got some curve to it. We have to select the bottom of the part and then make our box point on the top, and then flip our Z by clicking on the end of the arrow. Then we can go to stock, go from relative to fixed, and it's telling us in X we need 5.5 inches, Y we need 4, and Z we need 3.5. Now the only thing I'm going to change in here is model position from offset from top. Change that to 20 thousandths because that's my preference. Go to post process, change this to 8008 on the program number, to offset 1, which would be the same thing as G54. You don't need to put a program comment, but you can. Once I've done this, I'm going to click OK. And now I'm ready for my first bit of toolpath. So the first thing I'm going to do is I'm going to do a face cut. I just happen to have the Titans of Building Block Library in here, and I'm going to use it. So here's a 3-inch face mill. Select that tool. I'm going to use all the recommended feeds and speeds for it and click OK. It's going to make a very clean and simple toolpath. Then I'm going to go back and I'm going to profile this block. So I'm going to use 2D contour. The tool that I'm going to use can be found in the Titans library. Not Titans library, but the Fusion 360 libraries right here. If you don't use these, I highly recommend you do. Go to milling tools. If you happen to click on one that says turn libraries on, just turn it on. But I'm going to use a milling tool. I'm going to use a flat end mill. I'm going to use a 1-inch end mill because I'm going to have to edit this tool a little bit because the stick out is so far. We're going to mash select. It brings that tool in. We can then go back to our tool, right click, and edit the tool. You can only edit the tool after you have selected to use the tool if you're dragging a tool in from the Fusion library. All of our cutting parameters are found under cutting. I'm going to call this end mill 6 inches in length. The amount below the holder is going to be 3.6 inches. The shoulder is going to be 3.5. And the flute length is also going to be 3.5. Now, I've actually got an end mill spec sitting in front of me. So this is the specs off of that tool. Instead of 6 flute, we're going to call it 5 flute. And then we're going to click accept, select, and now we have a proper tool that is capable of actually cutting this part. Now I'm going to go to my geometry and I'm going to select the outside profile of the box. I'm going to go to passes, turn roughing passes on. I'm going to change this step over to 25 thousandths and my roughing passes to 35 thousandths. The tool is sticking out 3.5 inches. You're not going to take a very large cut with it. Once we've done that, we just simply click OK. Since we're not taking a whole lot of material off, it can be done in 2 passes. Now we are ready to do this contour. A couple different ways to do it. The way I prefer to do it is use this 3D option up here. Now my favorite is parallel. Parallel can be found right here. The tool I'm going to use, again, can be found in the Fusion Milling Library. Ball end mill, and I'm going to use a 5/8 ball end mill. Pretty standard size. That's the tool we're going to use. So we're going to go into geometry. We're going to do selection. select the bottom square. We're not actually selecting what we want to physically machine. We are selecting an area to machine. Now the software is actually smart enough in this instance to know not to overcut. We're going to go and add an additional offset of approximately 50 thousandths. We're going to go to our passes, and this is where we define how rough or fine of a cut we need. It's going to tell you the cusp height, which is the height between scallop to scallop. Right now we're 3/10. That's very fine for just about everything. But depending on the surface finish you're trying to hit, you may need it that fine. I'm going to speed this process up, and I'm going to do approximately 50 thousandths step over, which gives me about 2 thousandths cusp height. For what I'm doing here, it's more than enough. Once I've done this, there's nothing else to do. I'm just going to mash OK. And there is our toolpath. Wasn't that easy? Now the next thing we're going to do is we're going to come in here with trace. Trace is a very simple function to use. It's actually found in 2D right here. And with trace, we can select this middle area. And then we can just take a chamfering tool. The spot drill right here will work perfectly fine. Click select. Click OK, and see how it follows that actual outline. So the finished part, as you can see, it doesn't show any physical depth. One quick thing to note, something that I just noticed, is that in parallel before it wasn't cleaning it up here. So let's correct that. Right click on your parallel edit. Go to your geometry, and we put 50 thousandths in here initially. This needs to be 250 thousandths. That allows up to a 1/4 inch of the tool for runoff to allow to go down the side of this part to clean up this edge right here. And now that edge is perfectly cleaned up. This is probably not even noticeable on the part. Especially after a quick deburr, that will be gone. And that concludes it for this tutorial. One thing you can definitely practice doing is putting a vise in and importing a machine into your setup. That probably would be good practice for you to do. If you've got any questions, leave them down in the comment section, and I'll be glad to answer them. Make sure you like and subscribe, and hope to see you back.